Okay, good morning, everyone. So we are going to start just the standard confirmation. A screen is visible to everyone. And
Yes, sir.
Yeah, thank you. Okay. So just a very quick recap of what we did last time. We talked about in the last two lectures, actually. We talked about the conditional probability as well as the independence. The two topics are related to each other. So conditional probability, we defined conditional probability of an event A given B as the probability of A and B together divided by probability of B. This can also be written as probability of A and B happening together is equal to probability of B into probability of A given B. Or it can also be written as, is because probability of A and B is the same as probability of B and A. So this can also be written as probability of A into probability of B given A. Okay. So we also talked about independence. This was about conditional probability. Conditional probability. And what we actually mean by conditional probability is that you are given something, you are given an event that reduces your sample space, And in that reduced sample space, you need to find the probability of some either other event in the reduced sample space. And how do you find the probability of an event in the reduced sample space? We use the standard definition, the number of points that support A divided by the total number of points in the reduced sample space. The number of points that support A in the reduced sample space. Okay. So again, this applies to equally likely outcomes. If we don't have equally likely outcomes, we may need to adjust a little bit. Okay. Now, what is independence? Independence of two events, A and B, would lead to the following. Probability of A and B together is equal to probability of A into probability of B. If you can do that, then the events are independent. And if the events are independent, then you can write that. So if I compare this expression with the one here, that tells me that under independence, probability of A given B is the same as probability of A. So whether B is given or not given, if the probability of A does not change, even if B is given, that means A is independent of B. When A is independent of B, then B is also independent of A. We did a couple of examples last time. We'll do one more example. So I'm going to consider this, two dice rolling example. So example, roll two dice. And we define the events, and we define the following events. Let's say E1 is the event that the sum of the two dice is 6. Let me also define that the sum of two dice is 7. E2 is the event that the sum of two dice is 7. Let's say F is the event that first dice is 4. Now I need answers in the chat window. What are these probabilities of these events? Probability of E1, probability of E2, probability of F. First, probability of E1. Answers in the chat window. Probability of E1. probability of E1, that the sum is 6. Now, would be easier to draw where the sum is 6. The sum is 6 here, 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 here. So these are the points where the sum is 6. So what would be the probability of E1? Probability of E1, 5/36. Thank you very much. What is the probability of E2? E2. E2 is the event which is here. E2 is this guy. So the probability of E2 is going to be, probability of E2 would be 6/36. Answers in the chat window. Yes, thank you. Probability of F. Answers in the chat window. Probability of F. First die is a 4. First die is a 4. It's this event here. First dice is a 4. It's this event. So this is F. This is E2, and this guy here is E1. So the probability of F is 6/36, which is 1/6. Now I'm going to ask the question, are E1 and F independent? Well, we cannot answer this question unless we figure out if the product of their probabilities is equal to the probability of their intersection. So I'm going to ask this question, the equivalent question, are E1 and F independent? So is probability of E1F equal to probability of E1 into probability of F? Is this true or not? For that, I need to find the probability of E1 and F. What is the probability of E1 and F? Answers in the chat window. Probability of E1 and F. E1 and F. You can see the intersection of F and E1 from the figure. From the figure, you can see the intersection of E1 and F. Intersection of E1 and F. So there can be only one answer, either 1/6 or 2/36 or 1/36. Not sure which one is. Yeah. So probability of E1 and F, there is only one point. There is only one point which belongs to E1 and F. So this is the point. This is the point. ये वाला point है जिसपे E1 और F overlap करते हैं. So the probability of E1 and F is 1/36. 1/36. Is this equal to probability of E1, which we have found above, into probability of F, which we already also found above? So no, that's not the case. So they are not independent, which means they are dependent on each other, which means they are not independent of each other. Now, same question. What about E2 and F? Are they independent? So once again, ask the question, probability of E2F is equal to probability of E2 into probability of F. Is this true? So what is the probability of E2 and F? The probability of E2 and F is going to be E2 and F. See, the intersection is, again, this just one point. ये जो मैंने blue के अंदर इसको shade किया. So this guy is again 1/36. Now probability of E2 is 6/36 and probability of F is also 6/36. So this is 1/36. Okay. So that means yes, E2 and F, they are independent. They are independent. They are independent. Okay. So another way of finding out whether E2 and F are independent or not, or E1 and F are independent or not, is to find the conditional probability. Okay. So also,
sir.
Yes.
Sorry, why 1/36? 6 into 6, 36 by 36, 1. Left hand side wouldn't be equal to right hand side.
कौन सा वाला सॉरी?
सर ये प्रोबेबिलिटी ऑफ E2 into F, ये इसकी राइट हैंड साइड।
ये वाला आप बता रहे हैं, ये जिसको मैंने
जी सर, ये नीचे 6 by 36 मल्टीप्लाई बाय 6 by 36।
हाँ तो ये 1/36 होगा
सर। 1 नहीं आएगा ये?
1 क्यों आएगा?
6 into, ओके ओके सर, ओह सॉरी, मिस्टेक, आई गॉट इट।
Okay, no problem. Okay, now, so another way of looking at the independence of E2 and F is try to find out the probability of E2 given F. What is the probability of E2 given F? So let's take a look at the picture here. इस picture पे फिर दोबारा focus करते हैं, ठीक है? What is the probability of E2 and F? E2 given F. E2 given F. E2 given F means number of points in E2. Number of points in E2 in reduced sample space in F divided by number of points in F. We can do that because the outcomes are equally likely. If they are not, we will not be able to do that. So what is the numerator value? Numerator में क्या आना चाहिए? Number of points in E2 which also lie in F. Number of points in E2 which also lie in F. This is 1 divided by number of points in F, which is 6. Okay, which is 6. So this is equal to 1/6. And we can see that this is also the probability of E2 here is also equal to 1/6. This is equal to probability of E2. So we can see that the probability of E2 given F is the same as probability of E2, which means E2 is independent of F. उसकी probability जो है उसको change नहीं होती. If F is given, the probability of E2 does not change. If that is the case, that means E2 is independent of F. And vice versa is also true, but F is also independent of E2. Okay. Now, now I'm going to state something. If E2 is independent of F, which is the case here, and E2 is also independent of G, is also independent of G, okay, is E2 independent of F and G together, the intersection of F and G? Okay. The answer to this is not necessarily. The answer to this, I will give you the answer first. Not necessarily. कभी कभी हो सकता है ये आ भी जाए, but not always. So E2 is independent of F, which is the case here. ये अभी हमने देखा इसी example में. So I'm going to define an event G. I'm going to define an event G, and let me define this event G as the event that second dice is a 3. Second dice is a 3. और ये इवेंट यहाँ पे अगर हम शो करना चाहें तो ये कैसे शो करेंगे? Second dice is a 3 can be shown by second dice is a 3 is this event. Is this event. Second dice is a 3. Now you can see that second dice is a 3. इसका भी E2 के साथ इंटरसेक्शन 1 पॉइंट का ही आता है और show at home that E2 and G are independent. ये बिल्कुल उसी तरह से शो कर सकते हैं कि E2 and G उसी तरह इंडिपेंडेंट हैं जैसे E2 is independent of F. So F was the event that first dice is a 4. G is the event that second dice is a 3. E2 is the event that the sum is 7. Sum is 7. E2 is independent of F. E2 is also independent of G. Okay. So the question is E2 independent of F and G? Intuitively हमें क्या लगता है? Intuitively ऐसे लगता है कि शायद ये ना हो. Why? Because G is the event that the second dice is a 3, F is the event that the first dice is a 4. अगर G और F ये दोनों ही आपको दे दिए तो मैंने फिक्स कर दिए. Okay? Recall करें कि F was the event that first dice was 4. And G is the event that second dice is a 3. If F and G both are given, then we have already given you the sum. We have already told you that the sum of both the dice is 7, which means कि E2, which is the event that sum is 7, उसकी probability जो है वो conditional on F and G, वो तो 1 हो जाएगी. Conditional on F and G would be 1. Okay. So we can show that E2 is not independent of F and G together, although it was individually independent on F and also individually independent on G. But F and G agar both are given, then E2 is not independent on that. ये intuitively भी हमें लग रहा है कि F और G दोनों दे दिए तो आपने सम को फिक्स ही कर दिया, सम को आपने 7 कर दिया. जब सम को 7 कर दिया तो probability of E2 given F and G वो तो 1 ही हो जाएगी. Okay. Now, there is one proposition that I'm going to just quickly talk about. And the proposition is, if E is independent of F, when we say that E is independent of F, that means F is also independent of E. Okay? But we can say something else as well. Then E is also independent of F complement. So there is a mathematical proof for that, which is given in the notes. Please take a look at that. I'm just going to give you a Venn diagram proof, which is this. Okay? ये आपके पास event है F, this is F, and this is F complement. And let me just, ये वाला जो event E है, इसको किसी और कलर में ड्रॉ करते हैं. ये this is event E. So when E is independent of F, that means कि the proportion of E in the sample space, ये पूरा का पूरा red circle और उसका area divided by the entire area of the sample space, okay, is the same as the shaded area E and F divided by the number of points in F, the area of F. ठीक है? So अगर E का ये वाला shaded portion, ये जो red portion है, if this red portion divided by the F guy is the same as the total E divided by the total sample space, इसका मतलब है कि हमने यहाँ पर भी जो चीजें छोड़ दी हैं, ये same proportion के अंदर है. So that means the green shaded area divided by F complement would also be the same. ठीक है? वो भी सेम ही होगा, क्योंकि अगर इनका प्रोपोर्शन बराबर है तो जितना हमने पोर्शन छोड़ दिया है उसका, वो भी उसके बराबर ही होगा. सो दैट मीन्स के नंबर ऑफ पॉइंट्स इन E also in F divided by number of points in F. Okay. This is equal to number of points in E divided by number of points in S. Okay. Number of points in S. ठीक है. So अब ये देखें कि S में से आपके जितने पॉइंट्स रह गए हैं उसमें से F को निकालते हैं तो जितने पॉइंट्स रह गए हैं वो कितने पॉइंट्स हैं आपके पास? वो हैं नंबर ऑफ पॉइंट्स इन S minus F, और ऊपर क्या होगा? नंबर ऑफ पॉइंट्स इन E into F complement, E or F complement. There is also a mathematical proof. Please take a look at that. And then इस प्रोपोजिशन से एक और सब प्रोपोजिशन आता है. सो हमने पता चल गया कि इफ E and F are independent, then E is also independent of F complement. So think of F complement as an event. If F complement is independent of E, then of F complement should also be independent of E complement. Okay? So this implies that E complement and F complement are also independent. Are also independent. तो अगर दो इवेंट दिए हों वो इंडिपेंडेंट है, तो एक को अगर कंप्लीमेंट कर दें तो फिर भी इंडिपेंडेंट रहते हैं, दूसरे को कंप्लीमेंट कर दें फिर भी इंडिपेंडेंट रहते हैं. ठीक है. So I'm going to talk about independence of multiple events, independence of several events, independence of several events. If you are given events A1, A2, dot, 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 up to AN. Okay. They are independent. They are called independent. They are called independent if for any subset of these events, we have, अगर इसके किसी भी सबसेट के लिए हम लिख सकते हो कि probability of intersection of I is equal to I in the subset of AI for every possible subset is equal to the product of I belonging to the subset probability of AI. ये क्या कह रही है कि ये इक्वेशन यही कह रही है कि सबकी जो इंटरसेक्शन होती है वो उसकी probability is equal to the product of the probabilities. So in other words, it is just saying कि अगर दो ही इवेंट हो तो probability of A1 intersection A2 is equal to probability of A1 into probability of A2 if two events, if n is equal to 2. If n is equal to 3, then we have A1, A2, A3. Then A1, A2, A3, तो probability of A1, A2, ये आपके पास probability of A1, probability of A2 होनी चाहिए. Probability of A1, A3 should be equal to probability of A1, probability of A3, and probability of A2, A3 should be equal to probability of A2 into probability of A3. This is called pairwise. ये pairs बनेंगे, pairwise independence. But this is not it. This is not sufficient. Why? Because for all events A1, A2 up to AN, for these to be independent, हमें उनके हर सबसेट, for any subset of these events, हमें ये इंडिपेंडेंस चाहिए होती है for every subset of these events. Now, दो के सबसेट तो ये हमने निकाल लिए, तीन वाला सबसेट किधर से? So I also need A1, A2, A3 to be equal to probability of A1, probability of A2 into probability of A3. Sometimes it may happen that you have pairwise independence, but the three events together, they will not be independent because the last equation, this one, will not be satisfied. So तीन events के independent होने के लिए जरूरी है कि 1, 2, 3 and 4, all of these conditions are met. All of these conditions are met. Example आपको देते हैं. So example, let's say you have an event R1 is the event that you have rain on day 1. R2 is the event that you have rain on day 2. And they are independent. एक दिन की बारिश का दूसरे दिन की बारिश पे असर नहीं होगा. ठीक है? So rain on day 1 and rain on day 2. Okay? And let's assume हम assume करते हैं assume probability of R1 is equal to 1/2. किसी भी दिन बारिश होने की probability जो है वो 1/2 है. And also assume that probability of R2 is equal to 1/2. So if it is given to you that on any given day, the probability that you will have rain is 1/2 independently of any other day. Independently of any other day. So D is the event. D is the event. I'm going to define this. Okay, rain on exactly one day. So किसी एक दिन बारिश होती है, दोनों दिन बारिश नहीं होती. ठीक है, on exactly one day. Okay? So I'm going to find the probability of D. What is the probability of D? What is the probability of D? Answers in the chat window. Answers in the chat window. What is the probability of D? That you get rain on exactly one day. Sample space क्या है हमारी? Sample space क्या है हमारी? Markram is saying 1/2. What is our sample space? How many points in the sample space? Answers in the chat window. How many points in the sample space? So sample space में कितने points होंगे? 4 points होंगे. 4 points क्यों होंगे? क्योंकि ये देखें, ये आपके पास day 1 है और ये आपके पास day 2 है. Day 1 के अंदर रेन हो सकती है और नो रेन हो सकती है. नो रेन हो सकती है और ये रेन. इनफैक्ट ये ऐसे नहीं लिखना चाहिए, ऐसे नहीं लिखना चाहिए. मे बी better way of writing it is rain and no rain. Similarly, rain and no rain. So if you look at it, कि ये वाला जो दिन है, on this day you have rain. On this sample point you have rain on both days. Okay. On this sample point you have no rain on either day. Okay. इसको यहाँ पे लिख देते हैं. This is rain both days. This is rain no rain either day. किसी भी दिन बारिश नहीं. ठीक है. And similarly, ये rain on day 2 but no rain on day 1. Okay. So this is the sample point जो D में आएगा. This is also the sample point जो D में आएगा. So this is going to be 2 out of 4, which is 1/2. So the probability of D is 1/2. I'm going to ask you, what is the probability of R1, R2? We know that on the days when the rain is there, the rain on a given day is independent of the rain on any other day. So the R1 and R2, it is given that they are independent. So this would simply be equal to probability of R1, probability of R2, which is equal to 1/4. 1/4. Okay. Now, is this equal to probability of R1 and, well, it is equal to probability of R1 and R2 anyway. So let me just probability of R1 and D. Probability of R1 and D. What is this probability? Answers in the chat window. Exactly एक दिन बारिश हो और पहले दिन बारिश हो. Answers in the chat window. R1 and D. कोई आंसर नहीं? R1 and D की प्रोबेबिलिटी क्या है कि डे 1 पे बारिश हुई है और एग्जैक्टली एक दिन बारिश हुई है, which means कि डे 1 पे बारिश हुई है और डे 2 पे बारिश नहीं हुई है. डे 2 पे बारिश नहीं हुई है. So this is equal to 1/4. 1 out of 4. Is this equal to probability of R1, probability of D? Yes or no? Yes or no? Answers in the chat window. Yes. So probability of R1 into probability of D, probability of R1 1 over 2t, probability of D हमने निकाली 1 over 2t, so 1 over 4. So that means this is a yes, which means कि R1 and D are independent. Similarly, probability of R2D is equal to 1 over 4 is equal to probability of R2 into probability of D. Okay. So this implies that R1 and R2 independent, R1 and D independent, R2 and D also independent. So this establishes pairwise independence. Every pair is independent. Every pair is independent. Now the big question is, are R1, R2 and D, are three of them independent or not? तीन लोगों के, तीन इवेंट्स के इंडिपेंडेंट होने के लिए हमें एक चौथी कंडीशन भी चाहिए होती है, and the fourth condition is probability of R1, R2 and D. Is this equal to probability of R1, probability of R2, probability of D? Is this true? Is this true? Yes or no? Yes or no? What is the probability of R1 and R2 and D? Answers in the chat window. ये लेफ्ट साइड के ऊपर जो है इसकी प्रोबेबिलिटी क्या है? Well, the probability of this happening is 0. I am asking what is the probability that it rains on first day, rains on second day, and rains on exactly one day. Never gonna happen. Never gonna happen. So this probability is 0. So is 0 is equal to 1 over 2 by 1 over 2 by 1 over 2? Are they equal? Of course not. Of course not. So that means R1, R2, D, they are not independent, although they are pairwise independent. Although they are pairwise independent, but they are not independent of each other. Now, I'm going to quickly talk about some systems. वो कहीं पे भी हो सकते हैं, engineering के अंदर ये systems हो सकते हैं. So composite systems of components. Composite systems of components. So two types of systems I'm going to talk about. One is called the parallel systems. Parallel systems. Okay. So let's say you have a component, एक आपने ये device लगाया है, and you have another component and another component. There is some probability that one component will fail. Okay. So let's say you have 1, 2, ... up to n components, and you put them in parallel. What that means is कि अगर इनमें से कोई एक भी अगर काम कर रहा हो, तो काम हो जाएगा. ये आप ऐसे समझ लें कि आपने 10 लोगों को एक काम करने को कहा है, 10 में से कोई एक भी वो काम कर दे तो यू आर डन. 10 लोगों में से कोई एक भी वो काम कर दे, यू आर डन. सो पैरेलल सिस्टम्स में the parallel system will work. This system will work when any of the component will work, when at least one component works. Okay. So let AI is the event that component I works. And the probability of AI, assume that this is equal to Pi. So the probability that system works is equal to the probability at least one guy works. How do I find that probability? In order to find that probability, I can find the complementary probability. This is a trick that we often use, is 1 minus the probability that no component works. कोई component काम नहीं कर रहा. 1 minus the probability that no component works. ये complementary events हैं. At least one component working and no component working, complementary events. So this is equal to 1 minus the probability A1 complement, A2 complement, dot, 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 AN complement. Now, all these components are independent of each other, So I can write this as 1 minus probability of A1 complement, probability of A2 complement, dot, 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 probability of AN complement. Or another way of writing this is 1 minus product I is equal to 1 to N probability of AI complement. And what is probability of AI complement? What is probability of AI complement? The probability of AI complement is nothing but 1 minus PI. 1 minus PI. Okay? Because probability of AI is equal to PI. So probability of AI complement is 1 minus PI. Okay. Very nice. Okay. So I'm going to talk about the other system, which is a series system, which is a series system. Series system. Series system में you put these components in series. You put these components in series. यूं समझ लें कि इसके अंदर से ये switches लगेंगे. If all the switches are closed, then the current will flow from left to right. Then the current will flow from left to right. अगर इनमें से एक भी switch खराब हो जाए, बंद हो जाए, okay, the current will not flow. So this system works if all components work. Okay. Again, consider करें कि AI is the event that the first component works, A2 is the event that second component works, and so on and so forth. AN is the event that nth component works, and the probability of a first one working is PI. बिल्कुल वही वाली probability जो पहले define की. So in this case, the probability that system works is equal to the probability that all components work, which is equal to the probability that A1 works and A2 and A3 and AN. So all of these events occur. पहला component काम कर रहा है और दूसरा and तीसरा and nth. Okay. Which is equal to, again, by independence, the components are working independently. This would be equal to probability of A1, probability of A2, dot, 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 probability of AN, which can also be written as, product of I is equal to 1 to N, probability of AI, which is equal to same as I is equal to 1 to N PI. In general, एक सिस्टम जो है वो सीरीज पैरेलल का मिक्सचर भी हो सकता है. Can also have a mixed system. Mixed system किस तरह का होगा? Mixed system इस तरह का होगा. Mixed system इस तरह का हो सकता है. So this system will work when या तो 1 और 2 ये दोनों के दोनों काम कर रहे हो, या 3, 4, 5 ये तीनों के तीनों काम कर रहे हो. ठीक है. So 1 or 2 अगर if both are working, the system is working. If 3, 4 and 5 all three of them are working, then the system is working. ठीक है. So now I'm going to talk about a very interesting topic, which is about the order of happening of events, order of happening of events in independent repeated trials. एक एग्जांपल आपको देते हैं कि एक डाइस रोल करते जा रही हैं और उस पे आते जा रहे हैं. सो यू कैन सी वन ऑफ द नंबर्स 1 2 3 4 5 6. ठीक है. उसको बार बार रोल करें. ईच रोल इज इंडिपेंडेंट कि पिछले रोल के ऊपर क्या आया था. Each roll is independent of what was shown on the previous roll, or the one before that, or the one before that. All the rolls of the dice are independent. The number which shows is not dependent upon what appeared in the previous tosses, previous rolls. So now I will ask you the question. कि क्या probability है कि you will see a 4 before you see a 6. Okay? So that's the order of happening of events. What is the probability you will see a 4 before you see a 6? 4 और 6 के अलावा और भी कुछ चीजें आ सकती हैं जिनमें हमारा इंटरेस्ट नहीं है. हमारा इंटरेस्ट है 4 और 6 में. अगर 4 पहले आ गया तो मैं जीत जाऊंगा, 6 पहले आ गया तो कोई और जीत जाएगा. ठीक है. So I would like to figure out who will win. And by the way, this kind of order of happening of events is very, very interesting from the point of view of gambling. You know, many gambling games they use the order of happening of events as part of the strategy of the game. And if you can calculate the probabilities, these probabilities, you will be able to figure out that on average whether you will win or the house will win. जो gambling house है वो win करेगा या आप win करेंगे. अगर आप बहुत long term खेलें तो who will win in the longer run? So इसको example से हम clarify करते हैं. Example. Let's say you throw two dice and note the sum. Sum आपका कितनी values ले सकता है? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. ठीक है. So let's say I am interested in the event. Probability sum of 5 appears before sum of 7. Sum of 5 appears before sum of 7. Now यहाँ पे हमने 2 डाइस थ्रो कर दिए. पहले मैंने जो एग्जांपल दी थी वो एक डाइस की थी. कि एक डाइस को बार-बार रोल करते जा रहे हैं. What is the probability you will see a 4 before you see a 6? Intuitively, anyone wants to answer that question? What is the probability you will see a 4 before a 6? You will see a 4 before a 6. Intuitively, what should be the answer? Anyone answers in the chat window? एक डाइस को बार-बार रोल किए जा रहे हैं. सिंगल डाइस है. ठीक है. ये तो अभी दूसरा हम क्वेश्चन कर रहे हैं. But I'm asking that for a single dice, if you keep throwing it until you see a 4 or a 6, जब भी आपके पास 4 या 6 जो भी आ जाएगा आप स्टॉप कर देंगे. What is the probability you will see a 4 before you see a 6? Answers in the chat window. तो कुछ लोग 1/2 कह रहे हैं, कुछ 1/6 कह रहे हैं. देखें 4 और 6 के अलावा जो कुछ भी आता है वो हमारे इंटरेस्ट का नहीं है. हम तो रोल करते जाएंगे जब तक 4 ना आ जाए या 6 ना आ जाए. ठीक है. सो अब हमारे पास दो ही इंटरेस्टिंग पॉइंट्स हैं. वन इज 4 एंड द अदर इज 6. ठीक है. बाकी जो पॉइंट्स हैं वो अपीयर करेंगे लेकिन दे आर नॉट इंटरेस्टिंग फॉर अस. इफ दे आर नॉट इंटरेस्टिंग फॉर अस व्हाट दैट मींस इज कि मैं तो डाइस रोल करता जाऊंगा जब तक मुझे 4 या 6 नहीं मिल जाएगा. So the probability that you will see a 4 before you see a 6. Okay. So these two guys are fighting with each other. 4 and 6 are fighting with each other. कि कौन पहले आएगा. Okay. So if there are only 2 guys fighting with each other, intuitively मुझे ऐसा लगता है कि 4 और 6 जो हैं उनमें किसी को preference नहीं है. No, these are equally likely numbers. So 50% chance होना चाहिए कि 4 पहले आ जाएगा, 50% chance होना चाहिए कि 6 पहले आ जाएगा. We don't care about the other numbers. We do care about only 4 and 6. So 50% chance है that 4 will come before 6 and 50% chance that 6 will come before 4. Okay? So intuitively ऐसा लगता है कि 50% इसका आंसर होगा. And really the answer is 50%. So ये 1/6 जो हमने लिखा है ना, 1/6, although हमें पता है कि probability एक दफा रोल कर रहे हैं तो वहां पे 4 आने की क्या प्रोबेबिलिटी है, 1/6. बट हम एक की बात नहीं कर रहे हैं, हम तो कह रहे हैं रिपीटेड ट्रायल्स हैं एंड 4 is not fighting with anyone else except for 6. 4 is only fighting with 6. Okay, so I cannot say कि 4 के पहले आने की प्रोबेबिलिटी जो है वो 1/6 है, 6 से पहले आने की प्रोबेबिलिटी वो 1/6 है. No, that cannot be Intuitively, that does not sound right. That means if I flip the question and ask the question, what is the probability that 6 will come before 4? तो क्या वो 5/6 हो जाएगी? नहीं, वो भी 1/6 हो जाएगी. नहीं, these two are these, या 4 6 से पहले आएगा या 6 4 से पहले आएगा. These are the only two possibilities. These are the only two possibilities. Okay, so have to be 50%. Have to be 50%. And in fact, it is 50%. Okay? So ये problem जो है वो union of events से solve किया जा सकता है. Union of events से solve किया जा सकता है कि आपका I will skip that. वो हमने notes के अंदर दिया हुआ है. One way of solving that. I will skip that union of events method. I'm going to solve it with a very cute method, and it's called the method of conditioning. And we have seen this method. मैंने कहा यार कि आपको condition करना चाहिए. If I'm asking you what is the probability of an event that happens later, so you condition on something. Okay. So condition on trick is condition on what happens on the first toss, on the first roll or first throw. Condition on what happens on the first throw. How many possibilities of something happening on the first throw? 6 possibilities. There are 6 possibilities. 1, 2, 3. Some have आपके पास 12, not 6 possibilities. There are 2 से लेके 12 तक. You have 11 possibilities. You have 11 possibilities. Okay. You have 11 possibilities. So I'm going to define this event. So first throw of 2 dice, let's define the event F that sum on first throw of 2 dice, is 5. What is probability of F? Probability of F. Sum of the 2 is 5. ये हम यहाँ से देख लेते हैं. ये हमने ये पिक्चर बनाई थी. Sum is 5. इस पिक्चर को देखें और यहाँ से बताएं what is the probability that the sum is 5? What is the probability that sum is 5? 1, 2, 3, 4, 5. So this would be 4 out of 36. ये कौन से events हैं? मैं आपको दिखा देता हूँ. These outcomes are the ones. Sum is 5. This guy, and this guy. ये जो 4 मैंने blue shades की हैं. So these are the ones which will result in the outcome to be equal to the sum to be equal to 5. Sum of the 2 dice to be equal to 5. This is 4 out of 36. And what about sum is equal to 7? Sum is equal to 7. Should be 6 out of 36. So I define the event G that sum on first throw, sum of dice on the first throw is 7. We are only interested in sum of 5 appears before sum of 7. So what is the probability of G? Will be 6 out of 36. And the rest of the guys, I'm not interested in that. अगर sum मेरे पास 2 आ जाता है, 3 आ जाता है, 4 आ जाता है, या 6 आ जाता है, या 8, 9, 10, 11, 12 आ जाता है, I'm not interested in those. I am only interested in 5. अगर 5 नहीं आया तो मैं दोबारा 5 और 7 में से कोई नहीं आया तो मैं दोबारा से रोल करता हूं. जब भी 5 आया या 7 आया, I will stop. And now I need to figure out whether 5 will appear before 7 or after 7. Okay? Now, यहाँ पे हम ये नहीं कह सकते, intuitively we cannot say that there is 50-50 chance. Why? क्यों नहीं कह सकते? Why cannot we say that there is a 50-50 chance कि 5 जो है वो 7 से पहले आ जाएगा? सिंगल डाइस के केस में हमने कह दिया था कि 4 और 6 हैं, वहां पे 50-50 चांस है कि 4 पहले आ जाएगा 6 से. We could say that in the case of a single dice because 4 और 6 की किसी भी एक थ्रो में आने की probability जो है वो सेम है, 1/6 होती है. यहाँ पे ऐसा नहीं है. यहाँ पे 5 के आने की probability 4/36 है. It is more likely It is more likely that 7 will come. It is more likely that 7 will come. So मुझे लगता है कि intuitively feels if 7 is more likely to happen before 5. 7 is more likely to happen before 5. And let's figure out if it is the case. Okay. So let me also define the event H. Let me also define the event H that first trial sum on first throw और ट्रायल भी थ्रो भी कहते हैं, इसको ट्रायल भी कहते हैं. सो ये मैंने यहाँ पर लिखा था कि रिपीटेड ट्रायल्स मींस के रिपीटेड थ्रोज, एक्सपेरिमेंट को बार बार रिपीट करते जा रहे हैं. सो सम ऑन द फर्स्ट थ्रो इज नीदर 5 nor 7, which means uninteresting guy. I will throw again. I will be back to square one. If something else appears, I will be back to square one. I will be throwing again. Okay. Also define E is the event that we eventually win. और win को मैं define कर देता हूँ. Win का क्या मतलब है? Win का मतलब है 5 before 7. 5 before 7. This is the probability that we wanted to find out. यही तो हम find out कर रहे थे. So basically I am looking for probability of win, and win is 5 appears before the 7. 5 appears before the 7. इसको हम win कह देते हैं. आप lose कह दें, कोई मसला नहीं है उसमें, जो भी कह दें. But really you define this event 5 before 7. So eventually you will get 5 before 7. Eventually you will win. So the probability of E can be found by condition on the outcome. Condition on the outcome of the first event, of the first throw. Condition on the outcome of the first throw. कैसे करेंगे? So probability of E is equal to probability of E given F into probability of F plus probability of E given G into probability of G. Plus, ये partitions लिख रहे हैं हम. Law of total probability, probability of E given H into probability of H. ऐसा क्यों लिखा? ऐसा हम ऐसा लिख सकते हैं. ऐसा हम इसलिए लिख सकते हैं. From the last lecture, ये law of total probability है. This can be written because F and G and H, they are mutually exclusive and exhaustive. Mutually exclusive and exhaustive. You can draw the tree diagram and figure out. Now, probability of E is equal to, what is probability of E given F? Probability of E given F. Answers in the chat window. Answers in the chat window. Probability of E given F. F क्या है? Sum on the first throw is 5. And E is that eventually in the entire set of experiment, what is the probability that you will get a 5 before a 7? Oh भाई, अगर पहले ही throw पे 5 आ गया, अगर पहले ही throw पे 5 आ गया, तो आप तो win कर गए हैं. You will just stop right there. You will say, oh yes, यही तो हम चाहते थे, win हो गया. So the probability of win, given that you win on the first throw is 1. What is probability of F? वो हमने probability of F ऊपर निकाली है, 4/36 plus probability of E given G. Probability of E given G. Probability of E given G. I'm going to just write it probability of F for a moment. बाद में put करते हैं. What is the probability of E given G? 0. अगर आपको हमने बता दिया कि 7 आ गया, तो there is no way, अगर पहले throw पे 7 आ गया, there is no way you can see a 5 before a 7. There is no way you can see a 5 before a 7 because पहले throw पे 7 आ गया. ठीक है? So this is going to be 0 plus this third guy. What is the probability of E given H? Now this is tricky. Probability of E given H. पहली throw के ऊपर given H means something else. ना 5 आया है, ना 7 आया है. There is something else which shows up on the first throw. What is the probability of E given H? Answers in the chat window. I need some answers. What is the probability of E given H? Please. कोई तो आंसर करे इसको. Usman, can we roll again in this case? Of course, we keep on rolling. We keep on rolling until we see a 5 or a 7. Until we see a 5 or 7, we keep on rolling. जब तक ये जीत नहीं जाते या हार नहीं जाते. Very good, very good. So this is when you get a 5, you win on the first row. When you get a 7, you lose on the first row. When you get something else, then you repeat. Then you repeat. ये तो हमारा experiment ही ऐसे डिजाइन हुआ है, repeated trials हैं. Then you repeat. So that means if you don't get a 5 or a 7, then you are back to square one. आप उसी जगह पे खड़े हैं जहां पे पहले थे. Now the probability of E happening is exactly the same जो पहले थ्रो से पहले थी. जो पहली थ्रो से पहले थी, which means this would be probability of E. Okay. And probability of H, and the probability of H. Solve करते हैं probability of E के लिए. Probability of E, by the way, probability of H हम easily मालूम कर सकते हैं because F, G and H are mutually exclusive and exhaustive. So 4 by 36 plus 6 by 36, इसको 1 में से minus करेंगे तो we will get the answer. Okay. So the probability of E from here, would be equal to probability of F divided by 1 minus probability of H. And really, 1 minus probability of H is nothing but probability of F plus probability of G. So this is the probability of E. Remember, E is the eventual win, and F is win on first throw. F or G जो है, and G is the loss on first throw. Okay. So now you can see, okay, I can calculate this probability of F and G. This is 4 by 36, 4 by 36, 6 by 36. Okay. So this is going to be equal to 4 by 10 or 0.4. Which makes sense. देखिए, which makes sense. Intuitively भी ये sense बनाता है. क्यों? F के आने की possibility 4 by 36 थी on any given toss. G की possibility on any given toss is 6 by 36. It was more likely that 7 will come before 5. Why? Because on a given trial, 7 is more probable as compared to 5. 7 is more probable as compared to 5. And that is exactly what we have seen here. So you can see that this trick of conditioning what happens on the first trial is very, 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 very nice. ये काफी हेल्प करती है. इस प्रॉब्लम को वैसे सॉल्व करें तो मुश्किल हो जाती है. सो देयर इज अनदर प्रॉब्लम व्हिच इज कॉल्ड प्रॉब्लम ऑफ पॉइंट्स. वो भी हम ऐसे ही सॉल्व कर सकते हैं. प्रॉब्लम ऑफ पॉइंट्स बिल्कुल उसी तरह से सॉल्व किया जा सकता है. अगेन independent trials, that is repeated experiments. Okay, let P is the probability of success or win. बिल्कुल जैसे हमने वहां पे 5 को सक्सेस कह दिया था और 7 को फेलियर कह दिया था. In exactly the same way, let P is the probability of success and 1 minus P of failure. 1 minus P is the probability of failure. On each trial, एक सिंगल ट्रायल के ऊपर you will win or lose. We can modify this problem and can say कि हर ट्रायल के ऊपर you will win or lose or draw. Win, lose or draw. ऐसे भी कर सकते हैं. ठीक है? That would be just an extension of this problem. I am going to ask this question. Okay, what is the probability of, देखिए एक तो बड़ा सिंपल सा क्वेश्चन पूछ सकते हैं. What is the probability of winning before losing? What is the probability of winning before losing? That is going to be just P. क्योंकि अगर पहले ट्रायल में आप जीते नहीं तो आप हार जाएंगे. पहले ट्रायल में अगर जीते नहीं तो हार जाएंगे. So that would be just P. So in fact, अगर ये वाला formula भी अगर देखें, so this would be P over P plus 1 minus P, which is just P. Which is just P. So what is the probability of, now it's a different question, of accumulating n successes. मैं अब एक success की बात नहीं कर रहा, before m failures. अब टॉस करते जा रहे हैं, या पहले आपके पास n सक्सेसेस आ जाएंगी, n विन्स आ जाएंगे, या उस m फेलियर्स पहले आ जाएंगे. जो भी पहले आएगा आप स्टॉप कर देंगे वहां पे. नाउ द क्वेश्चन इज कि which will occur first? Will you be able to get 5 successes before 7 failures? Will you be able to get 3 successes before 20 failures? So this is a very, very interesting setup. इसको डायरेक्टली नहीं सॉल्व कर सकते, इसको सॉल्व करने के लिए इटरेटिवली सॉल्व करना पड़ेगा. इसको सॉल्व करेंगे इटरेशन से, बट वी विल यूज आवर ओल्ड ट्रिक वुड बी कंडीशन ऑन द आउटकम ऑफ द फर्स्ट ट्रायल, and the first trial can either be a win or a loss. Okay, so n successes before m failure. Let me define this to be an event. This probability is, let's say this is P and M. This probability is P and M. P and M is the probability of n successes before m failures. Okay, this will be equal to, देखिए इसको अगर मैं event E कह देता हूं, let me call this event E. This is equal to probability of E given success on first into the probability of success on first trial plus the probability of E given failure on first into the probability of failure on first. देखिए, अगर पहले ट्रायल पे आपकी सक्सेस आ जाती है तो आप स्टॉप नहीं करेंगे, आप चलते जाएंगे. Why? Because you have to accumulate n successes. Similarly, अगर फेल हो जाते हैं तब भी स्टॉप नहीं करेंगे. Why? Because you have to accumulate m failures. So now I'm going to ask this question. Okay, what is this first quantity? Probability of E given the success on the first trial. P and M is the probability of starting from scratch, seeing n successes before m failures. What is the probability of E given success on the first trial? पहले में success आ गई है. Now what is the probability of eventually this guy happening, n successes before m failures? What is the probability of that happening if you have already seen the first success? This would be simply equal to, एक success आपके पास आ गई है, अब आपने सिर्फ n-1 successes लेनी है. Now you only need n-1 successes before how many failures? Before m failures. Because failure तो अभी कोई नहीं हुई है, अभी तो एक ही success हुई है, एक ही trial किया है, उस पे success आ गई. And what is the probability of success in the first trial? It is small p. Plus, what is this quantity? Answers in the chat window. Probability of E given the failure on the first trial. Now you have one failure already registered. You only have m-1 chances now of failure wale. अब आपके पास, what is the probability of E given failure on the first? If there is failure on the first, you still need n successes. But now you need n successes before an additional m-1 failures into 1 minus p. So this is an iterative equation. इसको solve कर सकते हैं by using some boundary conditions, and boundary conditions here are P and 0. N successes before 0 failures. This probability is 0. You cannot have n successes before 0 failures. Before 0 failures आपके पास successes नहीं हो सकते. Because when you begin, you already have 0 failures. उससे पहले तो कोई सक्सेस नहीं हो सकती ना. When you begin the experiment, you already have 0 failures. ठीक है. तो उससे पहले जो है आपके पास n successes नहीं हो सकती. ठीक है. Similarly, P0, M is 0 successes before M failures. When you start, you have 0 successes. तो ये कितनी भी failures हो उनसे पहले occur करेगी. So the probability of this is 1. Probability of this is 1. Okay. Using these boundary conditions, we can solve this iterative expression. ये एक टेबल से बना के सॉल्व कर सकते हैं इसको, and it's given in the notes. Please take a look at that. ये एक होमवर्क प्रॉब्लम भी हमने दिया हुआ है, बड़ा सिंपल सा इसके लिए. इसमें
सर ये बाउंड्री कंडीशंस याद है
जी. ये मैं एक टॉपिक है वो खत्म कर लूं, उसके बाद बाउंड्री कंडीशंस दोबारा बता देंगे क्लास के एंड पे. ठीक है. So I'm going to talk about what we call conditional independence. By the way, conditional probability भी एक probability होती है. It satisfies all the 3 axioms of probability. Conditional probability is a probability. बेशक conditional है, उसमें sample space को हमने reduce कर दिया, but it is still a probability. There's a chance of something happening. And it satisfies the 3 axioms of probability. So I'm going to talk about the conditional independence, which is going to be the last topic before we start random variables next week. So conditional independence means that 2 events may or may not be independent, but given a third event, they can be independent, and vice versa is also true. So conditional independence को express कैसे कर सकते हैं? So how do you express conditional independence? Probability of A and B together given C is equal to probability of A given C into probability of B given C. If this is the case, then we say that A and B are conditionally independent, conditioned on C. एक और भी तरीका इसी को लिखने का, कि probability of A given B and C is equal to probability of A given C. Okay. But this also means is given C, probability of A is the same as probability of A given B. Okay. अगर C को हम छोड़ दें यहाँ पे तो देखें एक A given B है और एक A है. So when C is given, then the probability of A is equal to probability of A given B. वो कब होता है? वो उस वक्त होता है when A and B are independent. So A and B are independent given C, A and B are independent. ये दोनों equivalent है. Okay. Now conditional independence does not imply unconditional independence. आपको एक एग्जांपल अभी देंगे. कंडीशनल इंडिपेंडेंस does not imply unconditional independence and vice versa. So ऐसा हो सकता है कि 2 इवेंट्स जो हैं वो इंडिपेंडेंट हो, लेकिन अगर कोई तीसरी चीज दी हुई हो तो फिर वो इंडिपेंडेंट ना रहे. ऐसा हो सकता है. This is possible. Okay. Not always required, but it is possible. Okay. So I will give you an example. वही example आपको rainy day वाली example देते हैं. R1 is the rain on day 1. R2 is rain on day 2. And again with probability 1/2. And this is also with probability 1/2. And D is the event that rain on exactly one day. ये हमने इनकी पहले probabilities मालूम की थी. So 1/2 और D की भी probability 1/2 थी. Okay? Now the question is, are R1 and R2 independent? इट वाज गिवन कि एक दिन में जो बारिश होती है वो दूसरे दिन से इंडिपेंडेंट होती है, ठीक है। सो unconditionally means not given D or anything else. That is, not given anything else, they are independent. They are given to be independent. They are independent. Okay. What happens if D is given? What happens about independence of R1 and R2, which is rain on day 1 and rain on day 2? What happens to the independence of R1 and R2? What happens to the independence of R1 and R2 when D is given? So it turns out हमें तो इंट्यूटिवली पता चल रहा है कि अगर मैं आपको D गिवन कर दूं, if I give you D, that means I tell you कि exactly 1 day पे रेन हुई है, तो R1 R2 जो है वो इंडिपेंडेंट नहीं रहते. अगर R1 हो गया तो R2 नहीं हो सकता, अगर R2 हो गया तो R1 नहीं हो सकता. So this makes a lot of sense, right? If D is given, then R1 and R2 do not remain independent. R1 and R2 become dependent. In fact, a common question that sometimes students ask is कि mutually exclusive events जो हैं ये क्या independent होते हैं या dependent होते हैं? Mutually exclusive events, are they independent or dependent? If there are two events which are mutually exclusive, A and B, mutually exclusive, can we say they are dependent or independent? We can't say. Bilal कह रहे हैं कि we can't say. Anybody else? Can we say anything about the independence or dependence of A and B? Well, two events which are mutually exclusive, they are highly dependent. They are dependent on each other. क्यों? एक अकर कर गया तो दूसरा अकर नहीं कर सकता. So probability of A ये मालूम करें और probability of A given B मालूम करें. Probability of A given B is always 0. If they are mutually exclusive, probability of A given B will always be 0. Okay, and the probability of A could be anything else. And these two guys will never be equal. So mutually exclusive events are very, very dependent. क्योंकि एक हो गया तो दूसरा आकर नहीं कर सकता. इससे ज्यादा और क्या डिपेंडेंस हो. So now I will come back to this. ये बाउंड्री कंडीशन किसी ने पूछी थी. So we have a couple of minutes left जिसके अंदर हम ये बता देते हैं. So boundary condition is that we are interested in n successes before m failures. Okay? So what is the probability that you will have 3 successes before 0 failures? ये पहले वाली boundary condition देखते हैं. What is the probability of 3 successes before 0 failures? 3 successes before 0 failures. क्या हो सकती है? देखिए, जब आपने एक्सपेरिमेंट स्टार्ट किया था, हाउ मेनी सक्सेसेस डिड यू हैव? जब एक्सपेरिमेंट स्टार्ट किया तो 0 सक्सेसेस थी, और एक्सपेरिमेंट स्टार्ट किया तो कितनी फेलियर्स थी? 0 फेलियर्स. जब आपने एक्सपेरिमेंट स्टार्ट किया, you already have 0 successes. You start with 0 successes and 0 failures. When you started the experiment, even before the first toss, even before the first throw, you already had 0 successes and 0 failures. Okay? There is no way you can have 5 successes before 0 failures. क्योंकि 0 failures तो आपकी पहली थ्रो से पहले ही स्टार्ट हो गई थी. 0 successes आपकी पहली थ्रो से पहले स्टार्ट हो गई. So n successes before zero failures. Before zero failures cannot happen because when you started the experiment you already had zero failures. पहले ही आपके पास zero failures थी, उससे पहले कोई successes नहीं हो सकती. So the probability of this happening is 0. Does that make sense? ये जिनका सवाल था. Okay. Now the other boundary condition is probability of zero successes before m failure. उसी चीज को flip कर दें. भाई जब आपने start किया, even before the first toss, you had zero successes. And that was definitely before 1 failures or 2 failures or 4 failures जो बाद में कभी आएंगी. हमें तो पहले toss से पहले ही zero successes मिल गई. So the probability of this guy, second guy, is always going to be 1. It's always going to be 1. Okay? So इसको use करके and then n और m को आहिस्ते आहिस्ते इंक्रीज करते जाएंगे. 0 और 1 के लिए आपको पास वैल्यूज मिल गई हैं, आंसर्स मिल गए हैं. इसको एक एक करके इंक्रीज करते जाएं. Iteratively you can solve for p and m. 5 successes before 20 failures. You can find an answer to that kind of a question. Okay. एक ये टेबल ड्रॉ किया हुआ है नोट्स के अंदर, which I will upload shortly after the class, and then there is a homework question on that as well. So any other question about the lecture today or your topic? Any questions? Good question. So I will stop the share. And then close the session. Thank you very much for showing up in the morning. See you next week. In fact, before that, on Monday we have a quiz.